This is a lesson on z-scores. First, we're going to do one really simple problem and how do you actually calculate a z-score, and then we'll do a couple where we actually calculate them and then compare them, which is really the purpose. So here we have the formula. We have z sub I. I is just for any item in your data set, first, fifth, 100th, whatever term you're looking at, and it's associated with that same data number or data point. So this is the actual score from the data. This would be the mean, and this would be the standard deviation. So as long as you have those three things, like I have here, we're going to plug them into our formula to get our z-score. So z sub I is equal to the score, which is 52, minus the mean, divided by the standard deviation. So we're going to do the top, which is negative 3 over 1.5, and we get a score of negative 2. So our z-score for that particular number in this data set is negative 2, which means it's 2 full standard deviations below the mean. Now, let's take a look at these two problems. Again, the formula z equals x minus x bar over s. Now I could use different variables, like in the second example here with the math score. I'm using y's. On the left with the golf, I'm using x's. So let's do the golf in green. That just makes too much sense. So I'm going to do the score minus the mean over the standard deviation. I get negative 3.4 for the numerator, divided by 0.82, gives me a z-score of negative 4.146. That is my golf z-score for that particular score in that data set. And the math I'm going to do in purple. So we have our score, 670, minus the mean, 550, divided by the standard deviation of 60. The top is 120 divided by 60. So we get a z-score of 2. So we have two different z-scores here. Now we can use that information to compare the performance on each of the things. Now, generally speaking, you want to be above average. So if you're taking a math test, you want to be above the mean. And if you're trying to earn points or anything like that, the larger numbers are better. But in golf, smaller numbers are better. So in this particular problem, we have a z-score of 2, which is excellent, right? You're above the mean in math, but you're better. It's better to be lower in golf. So we have a z-score of negative 4.146 for the golf score of 73, which is well better than 2 standard deviations. But now we're below the mean. So in actuality, in this particular comparison, the golf score of 73 is better than the math score of 670. So we're allowed to compare data sets like that.